So here we go again. I think here's the good news for the online people. I think I totally did that first video with no sound. So I'm hoping this time it works, guys. There's going to be a lot of mad people. I'm just going to see the board behind me now. We got the other lecture. What I want you guys to see, and I'm not going to spend a lot of time in the second hour on this, I want you guys to review IH techniques. So we've gone through some of the sampling. I want you guys now to realize these slides basically talk about different techniques. In other words, once you finish the sampling, what do you do with it? And I want you guys to think about this now. If you're going to go sample something, what should you do before you even start sampling? What do you guys think? I mean, you've sat in your office, you've done the research, you've done your good assessment, and you say, guess what? I am going to sample for methyl ethyl bad stuff. What are you going to do next?
Get any PPE that I might need to be in case I'm overexposed.
Absolutely good answer. Yeah, okay, so you're going to protect yourself. We know that. What else are you going to do? And I want you guys to think ahead. Start with the end in mind. What are you going to do once you do that 8 hours of sampling? You do your 8 hours of sampling, you got your little sample, your pipes all calibrated, everything's perfect. What are you going to do? You're going to compare. Are you going to run the sample, or who's going to analyze the sample?
I would prefer somebody else.
Yeah, most of the time, I'm going to ask you guys, do you all know, let's say you're suddenly looking and you need metal analysis. Do any of you guys know how to run an inductively coupled plasma or an ICP? So where are you going to go for that?
YouTube.
Huh? YouTube? Yeah. It's like flying an airplane. There's a YouTube video on it. I can figure it out. Yeah, the labs. So here's what I want to challenge you guys on. All of these slides that are up here on the different techniques, and I'm just kind of going through them, here's the question you should do before you actually sample. Call the lab. Because there's nothing worse than having a sample and either shipping it the wrong way or creating a problem where you can't have it analyzed, okay? Or better yet, the lab you have, plus the lab will tell you, oh, wait a minute, don't use this media. You know, as we go through the methods, and there are different methods you'll look at, and you guys will see this, basically they'll tell you what to sample on. And all I did with this module and why I loaded this up, and we're not going to spend a lot of time on it, is just to familiarize you guys with, hey, what's an AA? What's an atomic absorption? What's it analyze? What analyzes metals? And understanding that, you can go to the lab and say, hey, do you have an ICP-AA? What samples can you analyze for? What are you looking for? Same thing with understanding how each of them work. Here's one of the big ones. Silica, this changed. You guys are going to do a little bit of work in here on silica, but this changed because guess what? There are new sampling media. We used to, back in the olden days, old curmudgeons like me used, basically a sampling device that now have been replaced by PPIs. Well, the lab will tell you, hey, we don't want the old sampling devices. We want you to use a PPI. So just kind of keep that in mind too. The other one as you're going through, I talked to you about chromatography, what it looks like, but the bottom line is, at the end of it, I want you to understand these detectors. So spend some time just hitting the slides, kind of talking through this. I added these in so that you would be able to talk to the lab. Don't go out and sample without talking to the lab. So I've got all these in here, different detection. I just wanted to flip through them with you guys. Lots of slides. This is for your own independent study. I am going to stop here and say, how do you know what even methods are available? Look at the board, and you guys will see it. The NIOSH, I want you guys to now Google this, and I mean this because it'll take you somewhere. Google NIOSH Manual of Analytical Methods, and this is the older one. What do you get when you do that? I'll do it too, just give you guys time to look at it. So what'd you guys come up with?
A 24-page PDF.
Yep. And what's it got in it? Right here it is. So what's it got? Numbers in front of compounds. So what do you think that is? And it actually describes different methods mean different numbers. So that's why I wanted you guys to see that. And then also, you can actually go in and find the compound. Since we seem to be hung on benzene today, let's see if you're monitoring benzene. Guess what? You're going to use method 8326. Oops, I picked the wrong one. Sorry. Let me go back. Benzene is 3900. When I said that, I knew that was wrong. But you guys can see, this is the canister method. You may say, wait a minute, I don't want a canister. I'm not going to do it that way. So guess what? I'm actually going to go up and look at some of the other methods, the 3800, where I do it by FTIR. Depends on what your method you're doing. But what you can do is actually talk to the laboratory and see what's going on. I thought bromine, Dave, I was going to show you bromine, but I don't see it under NIOSH. It's another method. But just be aware that these methods are out there, okay? And what I tried to do with the slide here was, again, give you every method so you could kind of go out and search different methods that you may want to sample. And again, I gave you some examples. I even gave you some air quality, some of the NIOSH methods, even the asbestos fibers. Okay?
Now, most companies will work for, they should have some sort of guidance for these chemicals already in place, right? Or
Yes and no. Normally they should, but depends on the maturity of their programs. I'll give you a good example. You may work for a company that's a startup, or you may have a new process, and guess what? You'll have to develop all this. Now, that's why you need the lab, to kind of say, hey, I'm being exposed to this. This is why it takes some time to develop the expertise.
now, on, let's say, a startup company,
Yep. By the way, there's still references here I wanted you guys to see. Go ahead.
how will we know what chemicals or toxins our employees are going to be exposed to?
Okay, so going back, in the U.S. and most companies, you have a hazardous material list or the right to know list. First place I always go is look at the process information. Look at what's being used, look at the SDSs, go through that. Usually you'll pretty quickly, if you apply the method we talked about in the first couple of slides, you'll see that you get pretty close on that. So I can't give you exactly where to go, but there'll be certain chemicals that your high usage of, you want to definitely look at. So it's really, it's why industrial hygiene is a science, but it's also an art.
So basically, if let's say I'm going to be starting a program,
Mm-hmm.
the first thing I would do is get an MSDS.
The inventory of the chemicals you're
Every
using.
single chemical that's being used.
Absolutely.
Then after that, I would then generate the
High-risk chemicals.
high-risk chemical list and then go into looking at my different exposure limits.
Yep.
For each.
And if you remember, and I'm going to go back a little bit, Dave, this was the process, what you're talking about right there, and I want to go back and show you guys this. I think I may have gone by it. This is when you know you wish you could find things quicker. Maybe I won't. If you remember one slide, I actually talked about the method, and I can't remember where that is, but in the first section, we talked about the method. There it is. This is the method right here. You're trying to anticipate, recognize, can evaluate, but the big thing you're going to do there is actually look at these limits right here as far as the risk assessment as you're going through it, okay? Does that help? That's what you want to use at the beginning. And this process right here, remember I told you hazard identification, then you're going to do exposure assessment, then you're going to see what's toxic out of that, then you're going to do your risk characterization, and that'll determine what you're going to do in your IH. And guys, what I can't tell you is your budget you're going to have. You may be limited. You may have to take highly hazardous the first couple years, then keep working through it. But if it's a startup, usually they've planned you to do that work.
Now, let's say the chemical, it has, 100 ppm for an 8-hour day.
Okay.
And the company then asks you, what your recommendations are.
Yeah.
Would a safe thing for your recommendation to be like 25% below that?
And we're going to talk about, that's where it gets into the uncertainty. And that's why where I will tell you, you want to always operate as in that 95% confidence level. And remember the variability we talked about? That's why you want to look at that. So you want to be 95% confidence. Now, a couple of chapters down the road, I'm going to give you what OSHA does when they do a sample. There's a formula they use to kind of go through that. But what you want to be is 95% or greater certainty of your sample results.
Okay, so I guess it's kind of...
So here, I got to answer this. So how many samples do you have to do statistical analysis? I'm going to give you a real gross number, 7 samples. Usually it takes 7 to get a good statistical database.
7 8-hour shifts.
Right, absolutely. So what's that run into? Lots of resources. It's money. And your time too. By the way, you guys are valuable too. Go ahead.
If I do an email, can I get that formula?
One of the things, you guys, no matter what you're doing, if you have questions, shoot me an email. If it's something that you think's absolutely urgent, call me. Now, I warn you, I'm an old guy. I go to bed about 10:30, 11 o'clock and don't get up till 5, 6 in the morning. So if you call me during that time, don't think I don't like you and I'm not answering the phone. It's because I'm asleep, okay? So I know you guys may keep later hours or better hours than I do, but I'm an old guy. But always shoot me the email and I'll get back to you. Other thing, if you email me and I don't get back 24 hours, email me again, okay? Don't take offense to that. Say, Ellswick, are you awake? Did you not wake up from your nap? So go through that, okay?
And call your cell and not your office.
Yeah, please do not call my office. Call my cell. The reason I don't say my office, now, if it's during my office hours, I'll be there. Tomorrow from 9:30 to 11, I'll be sitting in there. Okay, but people still call my cell, and that's cool. For you guys online, you don't realize I'm down in the dungeon. These guys do, so sometimes cell coverage is kind of spotty. I usually get them, though. So again, I wanted you guys to see the methods. Again, this is kind of a different sampling. I want you to spend some time. The biggest thing you can do with this is use this for reference, and I'm going to use it as an example. If you were analyzing benzene, what do you think the lab would analyze it on? What do you guys think? What type of sampling would they do? What do you think the media would be? Charcoal tubes? Yeah, it probably is. What about this? Would it be air sulfur dioxide, sulfur? And you see all the different methods there. And I tried to, at the end, give you guys exactly, Dave, what you were talking to. Some terms that you need to understand. Accuracy, bias, breakthrough. Basically, the way the sample tubes are set up, there's a front section, there's a back section. If your flow's too great, it'll break through. And guess what? That means your sample may not be valid. And here's some different terms you can talk about for quality control. So again, that whole section's about laboratory, okay? Here's what I'd recommend. Go through, read that, spend more time on the first part of that presentation, then look at the second one, kind of read through. The reason I want to bring that up occasionally in the questions, it's going to mention the industrial hygienist used gas chromatograph with an FID. What I am bad about, I'll say exactly that, GCFID. And you'll go, what is that? That's why I gave you the presentation, okay? Make sense? It's more for your information, plus you'll look really smart when you're out there trying to go through them. So let's spend a little bit of time, and I want to talk about exposure assessment. Dave, kind of what you talked about, but here's what I want you guys to walk out of this with. I want you again to understand how the OELs are determined. I want you to understand the outline on the process, how we get deviations, and the other thing as I close this door, I want you guys to apply the information. So let's talk through this. Kind of the role of the occupational exposure limits in risk assessment. You guys have seen this before. Hazard characterization, remember we talked about dose response, toxicity, and we talked about exposure assessment and risk characterization. Here are the importance of it. Guys, these are evidence-based. This isn't Bubba Joe or Sally Sue or somebody in there making up numbers. These are based on evidence. And they promote risk communication. In other words, it's not just us going out with numbers. There's a lot of research on this. And the other thing, you get some benchmarking too. So you can actually compare that. So I want you guys to do this. Stand up for a second, okay? Everybody do this. So for the people online, I'll show you. So I want you to put your hands together. So who has the right thumb over the left thumb? Anybody here? You're right over the left. Give me a little shake if you do. All right, you're left. Everybody's left. Well, I'm right over left. Guys, that means I'm a thinker. Now, you guys are left over right. What's that mean? Means you're romantics, okay? So, now, that's all right. Kick it back. What if your thumbs are together like that? What's that mean? You think you're romantic. No, I want you to do this. Put your hands back together the way you had them. Now, flip your thumbs. How's that feel? Shaking your head, no, what was that? Not comfortable. Okay, go back. Why does it feel comfortable like that? You guys go ahead and sit down. Why does that feel uncomfortable when you try? By the way, I seriously, I'll tell you when I lied to you. I lied to you about the thinker and the romantic. How do you think we learned how to fold our hands? How did you guys learn how to fold your hands? Did somebody tell you how to do it? What'd you do? You just watched somebody, didn't you? Here's your amazing thing. Families will all fold their hands the same way. Because guess what? They learned it all the way down through there. So that's how you really did it, guys. Psychologists tell us that's how we did it. Why, when I traded it, did it feel uncomfortable? You think, why is that so uncomfortable? Why, guys? It's change, isn't it? Change is difficult. So a lot of the stuff I'm going to tell you on occupational exposure limits, you're going to say, wait a minute. Here's your best thing you're going to say. As a benchmark, if you're trying to change someone's mind, you're doing exactly that with their thumbs. You're making them uncomfortable. What do you mean I can't be exposed to that? I've been exposed to that for many years. Well, we're basing it on data, and that's part of your risk communication. Remember that little drill if you're ever trying to explain to somebody why you're going to change things. It's a good thing to demonstrate that. Just don't tell them the romantic and the thinker. Actually, it's funny. So, you guys, this is a real formal, busy chart, but it talks about what we said earlier. Sit in your office, do your research, phase 1. I am basically looking at every type of problem, the formulation, the scope, and then I start my planning, my risk assessment, and utility. Phase 3 is where I really head out and start doing the work. And if you notice on each of these, they go back around. So I just wanted you guys to see a formula, kind of a graphic representation of risk management and risk assessment. So the OEL, or the occupational exposure limits, basically the concentration. We've talked about TWA, and you guys have even seen the additional notation, skin. Remember the A codes for benzene? Everything we did on page 12 and there. So, this is why I gave you guys this. This is what you should look at. I know the other presentation talked about it. This gives a really good explanation of all the different compounds, okay? And if you look at it, I tried to give you overseas, I tried to give you NIOSH rail. This is my list that I show people when they ask me. Now, I'm going to tell you my bias, and I don't want to bias you. By the way, you're always right, Dave. I worry about the O-Chappelles, but I'll tell you that ACGI-HTLV, you'll hear a lot of the industrial hygienists referred to, and especially, guys, international companies. They'll go to that. And Dave, you hit the other one. Occasionally, they'll go to company-specific occupational exposure limits. But I want you to know that ACGI-HTLV is up there. By the way, this comes out of the booklet I gave you guys earlier, you know, and you can use these definitions on there. They're defined in your booklet, okay? And for the guys online, they have this in the presentation. So, again, what's the short-term exposure limit? Somebody asked you guys that. I put it up in front of you. What would you tell me about short-term exposure limit? One thing. How long short-term?
15 minutes or less.
15 minutes or less. What else? What's it say up here? Guys, I want you guys to make sure you're awake. Can I ever exceed the 8-hour TWA in that stale? No, I can't. So that's what it's telling me there on those. What about the ceiling limit? And you guys, I am from a region called Appalachia, West Virginia. When I say ceiling, probably sounds different. You guys will notice. By the way, if I ever say a word and it's wrong, what did you say? You can say it. We talk about a ceiling limit. What do I mean there? What's the ceiling in this room? Yeah. Yeah, so that's the maximum. Should you ever exceed it? Never. Period. Now, I'll tell you guys, here's your caveat. What if I've got an IDLH that is lower, so immediately dangerous to life and health, and a ceiling limit? Let's say the IDLH is 50 ppm, the ceiling is 100 ppm. What can I expose someone to? Why is that? Immediately dangerous to life and health. You never want to exceed an IDLH, even if there is another limit, okay? Kind of a trick question. I think there's actually some questions I ask you guys on that, so be aware of that, okay? So the other thing, hazard notifications. You guys know this, skin sensitization, carcinogenic compounds, things like that, okay? And that's your A codes. We talked about the A codes, all that. Here is your fundamentals of your occupational exposure limits, how they're derived. And if you guys, I talked about this, I hope now you understand it. Basically, you scope out and develop the problem, you gather, you select a point. Notice most of this is done in your office, like we said. You do the research, then at the end, you'll go out and do some extrapolations, do sampling, and again, you need to understand. Now, we're very blessed here at Findlay. What do we have here that a lot of people don't have? I have had probably 2 of them in my career. One of your professors, what's her background?
Epidemiology, and they've got the air labs.
Yeah, PhD toxicology. So when you guys run into a toxic compound, or you wonder about, let's say you're reading an animal study or something, you need to go ask her questions. This is her expertise. I tell people all the time, just so you guys know, on the CIH exam, they have a toxicity section. I am proud to say that was my lowest score of any of them, okay? And people go, oh my God, I can't believe you're saying that. No, I'm proud because that's the section that's the hardest on there. This is difficult stuff. And toxicity, you need that PhD, you need medical doctors, you need to pull all of them nurses together. So you guys can now make fun of me. So the other thing we talked about some terms, no observable adverse effect level. We talked about lower observable, so these are the lowest dose that can cause an adverse effect. And then I love this POD, point of departure. Basically, it sets up the boundaries where you're going to cross over there. Simple terms, here's a beautiful chart. And you guys notice I even threw the uncertainty. So we kind of hit this, and I wanted you guys to see this. The OEL is basically that point of departure divided by your uncertainty factor. So if you look at it, it makes sense with this, because I'm going to ask this. If you had an employee, what would you want to expose them to? Let's say this is your chemical here. It goes along. How much would you want to expose them to? Would you want to go up to the no observable? No. Yeah, the NOE. So you're still not exposed, right? Well, by the way, why is the OEL set over here? What would you want to be exposed to? Nothing. Thank you. That's it. That's your safety factor. So that's why I want you guys to realize a lot of the times the OEL is set up a lot lower than, here's the one that always kills me. Somebody says, well, I wouldn't mind going to the lowest observable exposure limit. So in other words, you're going to have a reaction to the chemical. That's okay. That's the lowest. I'll be okay. And if you look at it, your response is really low there, isn't it? Would you want to expose yourself to that? And most people say no. Would you expose your employees? Well, maybe. No, hopefully not either. Well, that depends on who it is. No. Yeah, that's what I say. So again, you guys, I tried to give you a chart with all the definitions in it. Again, this is for you guys to study, read, look through. Again, when I give you reading in patties and different things, you can look at that. And then, of course, here's your OEL selection. I kind of talked to you guys about how to do this. Obviously, start with the PELs, work your down ACGIH. That was in the other presentation. Here are exactly what we talked about earlier, quantitative health effects. Here are all the traditional ones that you'll hear me talk about. Here's some provisional, and then thank God now in Europe they've actually got the REACH standards that these are very prescriptive. And it's interesting how they're developing those, and it's good information that you want to stay aware of. All the way down, I love if you guys ever go to Great Britain, the United Kingdom, England, whatever you want to call the wonderful island, they have these wonderful banding strategies. It's really big in pharmaceuticals. So that is really cool data. I did about 8 years ago my first class. It was taught by a Brit that I knew from Bear Crop Science. It was an incredible class on banding. I still love it. It's just, Dave, why do I go to regulatory? Why do I go to OSHA standards? Why do you think I always go to there if I have to for a client? That's the law. That's it. Now, if they ask me if I'm able to do it, a lot of the research I do, I'll drive it towards some of these prescriptive or even provisional standards because I know they protect health. So any questions on that one, guys? Feel good about it? Okay, there's your couple of presentations. I want to do this right now while we're going through this. And if you've got your computer with you or something, I want to show you guys this. So let's talk about where you're going to go on this. So if you look at the guidelines this week, or basically Canvas, you're going to see I loaded up, and we talked about the first week, everything there. But notice in the second week, I gave you guys all the presentations there. Then I talked to you about reading different handbooks and different chapters in Patty's. And I want to use this for an example. say chapter 1.7 in Patty's industrial hygiene text, okay? And you notice that I also have Patty's down here. So I want to show you in 1.7. So where are you going to go? And if you guys, I'm assuming, go to the library. Have you been to there yet? Did they go through that? Then you hit the LibGuides, and you go down to this wonderful Ellswick ENV 605. When you pop over to here, you're going to see Patty's. Now, what a lot of people will do, they'll actually go straight in to the handbook. And if you do that, you're going to get this, which is really not useful. You're just going to get a lot of information. Here's what I want you to do. If you remember, what section were we interested in? 1.7, Human Health Risk Assessment. Watch this. When I copy this into the search engine, because this is organized, what do you think is going to pull up? There you go. And there it is. By the way, you can click on this PDF, download it, and there's everything. So you guys see where I get the information? Does it make sense now? And hopefully this helps some of the online too. You don't need that anymore, Dave. I was actually showing Dave some of that. So you guys see that reference. The other one, Denardi's. I asked you to read. I want to make this clear. This book, there's only a first edition in print. We're fortunate enough that basically Salvatore basically gave us permission to use this book before it was released. Now, I don't know if he's ever going to release it, but he did some updates. So this is, I mean, guys, the people have criticized and said, well, it's not published. Or you can go back to the first edition that's really outdated, or you can take this. Plus, I'm giving it to you free. When you click on chapter 1 here, you're going to get this occasionally where it will ask for your user ID, which is your friendly ID, and then it's the same password you always use. And there you go, chapter 1. And again, you can download this. Notice right here I can download it and save it, okay? You guys got it? So I tell you how to kind of find things in there, hopefully help out. The other thing that I did too, I want you guys to know, there will always be things in here. I gave you a quick letters, Patty's, toxicology. The one that I'll use occasionally, if you remember last week, I believe I gave you guys, pathways. I did 2114, right? So if you take 2114 in toxicology, open it up again, take the time, put it in the search engine, guess what pops up? What you read last week. And I know you guys already knew this, but there it is. And again, you can go in and find that, pull it up, read it, do whatever you want to do. Does that make sense now? Scary, scary, right. By the way, and Patty's, both of them are very updated. They'll update with articles. One of the things I want to show you guys, once you search there, you may get underneath what I've told you to look at, you may be interested in toxic chemical research, and here you can read more about things as you're going through there. So that's the advantage of getting this online and not buying the book. If you have access online, it's always updated. So you guys got that one? Let me make sure I'm going over everything in there. Yeah, if you need resources, here are basically your APA style for sources, the intro. One of the other things I want to show you guys is basically you do have AIHA journal, you've got professional safety. You can go in and do those. Let's say you want to go into professional safety, you click on that and you can actually go through ProQuest and do that. Same with the other journals, okay? The one other thing I want to show you under LibGuides again is once you go into environmental science, for those that don't know, if you click on there, you also have this wonderful thing called Westlaw. If you're ever looking for a legal case, you can go in there and look. I know a few of you are laughing that had the Westlaw class, or the state legal class for me. Here's another thing you have, the STP, which is basically specialty, and you can go in. Let's say you're looking for a checklist on, and I always say this, let's say you want to find about, I don't know, let's do material handling. Here's a good checklist. You can go down and some of the OSHA standards. It is based on OSHA standards, okay? Now I've loaded up all the learning. Any questions on that? Let's go back to one more PowerPoint. So let's go through this on gases and vapors. I want to spend a little bit of time on gases and vapors. We're going to talk a little bit about the problems, okay? So, gases and vapors. Again, learning objectives. Why do I show you guys those? Kind of what I hope you can pick up out of there. Dave, I always worry when you start looking, am I getting behind? So I'm doing good. Don't hold it against me. So, here's your thing. NTP, normal temperature pressure. Dave and I, before you guys came in, had a discussion about what units do you like, and I'll use the first one up there. What do you guys use for atmospheric pressure? Do you talk atmospheres, millimeters of mercury, inches of mercury? What do you guys use? PSI? Yeah. So you do 29.9, perfect vacuum? Yeah. You can go through some of those. Here's what I always show this. You guys, I use this with the undergraduate class, but I want you to see this. This is my favorite little block, so let me show them. So there's your 1 mole, there's your 22.4. Here's my favorite gas law you guys see here, and I'll pass this around. And here is 1 mole of standard temperature pressure. This little box I had created, by the way, Avogadro's number. I had this box created so you could always have a reference for that STP. Pretty cool box, isn't it? It's got all of it there. It'll always be in here for tests. Sorry, the guys online, you'll just have to remember the box. So anyway, you can pass that around. Here's one of the formulas that we talked about last week. I wanted to make sure you guys had this formula and at least understood it. And by the way, where's this 24.45 come from? Where is it on the box, Dave? 24.45.
1 mole of standard pressure.
There you go. 1 mole at STP, 22.45 liters. There you go. So see, I'm not just making this stuff up. I have a box that says it, so it's got to be right? Okay. So vapor pressure. I get a lot of questions. What's the difference between atmospheric vapor pressure? Kind of gave you guys the definition there, what you can do with that, and then vapor density. So I want you guys to do a trick for me on your computers. Type this in, and I'm going to write it on the board. I'm even going to write it so they can see us. I want you to do mice. So you don't have to put a space in there, but you can. Type in mice into your search engine. What pops up?
Evolution and hazmat acronym?
Yeah, hazmat acronym. So what's that hazmat acronym? mice. What's the first H stand for?
Hydrogen.
Yeah. So what are these mice? Hydrogen, what's the next one? Acetylene? Argon? Ammonia?
Helium.
Yep.
Acetylene. Methane. Illuminating gases.
Yeah. So my question is, what's mice mean? What do all those have in common? And it says it in your definition there. What are all those gases? What's the density on them? Are they lighter or heavier than air? Okay, check it and see. What's it say? What's it say about what happens to them? Do they float or sink in air?
Lighter than air.
Yeah, there you go, lighter than air. Thank you, guys. So here's an acronym. I just use this. It kind of hits every compound, this mice now. There are a few other ones, but these are the major ones that are lighter. I just taught you guys lighter than air. It's a really good trick to understand with gases, some of the vapor density. So if you see the density, if you do mice, chemicals with lower vapor densities tend to rise, and chemicals with higher vapor density settle near the floor. Now, why do we worry about the ones that settle near the floor? Yeah, basically they can find flame sources, all kinds of open ignition source, absolutely. Specific gravity, we talked about this a lot in the first section. Basically grams per milliliter or centimeters cubed. The other thing, flash point, where it gives off ignitable, fire point, where it catches on fire, auto ignition, I'm not going to spend a lot of time on those. And then Brownian motion, basically it's how things move around and bounce around. Here's your diffusion, and I love this beginning and end. Notice what happens. It's just like you go to a party, you're hanging with all your friends down here, all of a sudden you see some interesting friends up here. What do? Before long your friends are all spread out. It's a terrible analogy for diffusion, but it works. And then you meet a wonderful person, you fall in love, you get married, yeah, it all goes well, right? Okay. So, ideal gas law. You guys, I will tell you my bias. I love the ideal gas law. So you guys will have problems on it. Why do I love it? Basically, I think it's used a lot for different chemicals and different reactions. So I'll make sure you see that. Here's your generalized gas law. Somebody caught an error, and I'm wondering if I do this. I don't know where, and I got to give a shout out. I can't remember who it was. I actually had one of the T1s, P1s messed up. I think it was either Charles' law or Boyle's law. So if you guys have an earlier presentation, I somehow got a V1 in there, so I put, maybe it's the next one. Yeah, I think it was there. I actually put T1 in there. But Charles' law, basically pressure over temperature, P1 over T1 is equal to P2 over T2. So, you guys, if I have the same temperature, and I increase the pressure starts at 10, and I increase it to 20. What's going to happen to the temperature? So I start at, let's say I start at, you guys work this out, I start at 25 degrees C. And my first pressure, and you can make up your units, is 10 psi. My second pressure is 20. What is the temperature number 2? Yeah. So P1 is 10, T1 is 25, P2 is 20. What's T2?
Should be 50.
50?
Yeah.
What was that?
50.
Yeah, 50. So does that make sense? Why is that? What was P1 compared to P2? Double. T1, T2. Just something. So here's the reason. I know that's a simple example. You guys are going to go, we're graduate students. Don't waste our time on junk like that. Sometimes, if you think through what makes sense, because I'll tell you, think about this. You guys, I'm talking American football. A few years ago, they had Deflategate, where suddenly they said, oh, the ball's deflated because the temperature went down. Well, think about it, guys. If the temperature went down, what would have happened to the pressure? It would have went down. It goes down, doesn't it? Hey, that's what happened. Yeah, but the problem with it is, think about how much that temperature would have to dip to get that much. Anyway, I'm not saying if there's Patriots fans out there, I'm sorry. I'm not challenging your
Actually, all
team.
you have to do is when you inflate it, you can either confirm or deny. If you heat up the room to 150 degrees while you're inflating it, then when you play the game in the wintertime,
Yeah, everybody deflates it, doesn't it?
deflate gate
Hey,
possible.
only you, Dave, would take us to that. That's it. And then Boyle's Law, the same thing there, guys. I want you just to be aware of how that's used. So, we're going to kind of do this because I want to take a quick, we've been at it going pretty hard. I want to take about 10 minutes. I want you guys to take a break and then come back and we'll finish up, okay? So come back in about 10 minutes, okay?